Okay, in this last section of Unit 3, we will talk about L'Hopital's rule for indeterminate forms when you are evaluating limits. And remember, going back to Unit 1, our ultimate goal is to be able to evaluate a limit by using direct substitution. So, if you're given the expression, the limit as x approaches a of a given function over another function, and after using direct substitution, okay, you get either 0 over 0 or infinity over infinity, or maybe negative infinity over negative infinity, or you could have negative infinity over infinity, or vice versa. Okay, so remember this is after direct substitution, excuse me, where x is equal to a. This is called an indeterminate form. Okay, and L'Hopital's rule will convert the given indeterminate form into a limit involving derivatives. Okay, and it's going to make it 10 times easier. So, if f of a and g of a are equal to 0, and if their derivatives exist, meaning that g prime of a is not equal to 0, then what we're saying here is that if you're given the limit as x approaches a over f of x over g of x, and remember if these are equal to 0 by plugging in a we get 0 over 0, then what you can do is evaluate the limit as x approaches a of the given derivative evaluated at a divided by the given derivative evaluated at a. And here they said that g prime of a can't be equal to 0. So L'Hopital's rule will also apply if you plug in a here to the original and you get infinity over infinity. So it's going to give you something like this or something like this. So conceptually what we need to do is just double check what we are going to get. So typically when we see something like this, 0 divided by a positive or a negative number, we know that the answer is 0. But here, if we see that a number is divided by 0, typically we would say, oh, well, it's undefined, or you can't do that. But if we're dealing with the limit, what we're saying is that our value is getting really, really, really close to 0. Meaning I take a number, I don't know, let's say 10, and I divide it by a really small number, so close to 0, but they're both positive. So divided by point, okay? So this is close to 0, not equal to 0 though. I get a huge number here, right? I could put more zeros and get even closer to 0, but not be equal to 0, and this is going to get even bigger. So this is going to get close to infinity, meaning I'm not equal to 0, I'm getting really close to 0. Okay, do the same thing here. If you have a negative number, so if I just recall my entry just like this, and I make this 10 negative, I'm just going to go towards negative infinity. So then this last value, right, or this last concept here, again, we can't divide by infinity because infinity is not a number. However, we're saying that this number right here is huge, meaning a really, really, really large number. So it doesn't matter if the top is positive or negative. If I take 10 divided by this huge number here, this right here means 0.11 or 0.00000. I have 8 zeros there and then a 1, meaning this value is so small it's literally close to 0 or almost equal to 0. So conceptually you need to understand these. So here we had this back in Unit 1, but now I'm going to show you how L'Hopital's works. So first of all, if I use direct substitution when x is equal to 0, because that's a limit that I want to evaluate, okay, I plug in and I say, all right, find the sine of 0 over 0. Well, first of all, already dividing by 0, I know I can't do it. Plus the sine of 0 is 0. So this is indeterminate. So what I want to do is use L'Hopital's one time. So I've got the limit as x approaches 0. The derivative of sine is cosine. The derivative of x is 1. Try direct substitution again. So direct substitution when x is equal to 0. Cosine of 0 is equal to 1. You're done. That's your answer. If you go back to your concept cards, you're going to see that this is in there. Let's take a look here. In C, we want to evaluate the limit as x approaches positive infinity, meaning I'm going to plug in a humongous number. So if I use direct substitution, when x is equal to infinity, ideally a humongous number, okay, we're going to take the natural log of infinity, natural log of infinity, over infinity. Already this is over infinity. The natural log of infinity is an infinitely large number. Okay, indeterminate. So this is not going to work. So now we will use L'Hopital. So we're going to say the limit as x approaches positive infinity. Okay, take the derivative. This is 1 over x over 1, because that's the derivative of x. Okay, again, plug in a large number. So now this is where we need to go to our concept check. We are going to use direct substitution. Okay, and we're going to say 1 over infinity. Ideally, we know we can't divide by infinity, but we're saying if this is a huge number, So look, some value, 1 is a positive number, divided by a huge number gives us 0.